Now we will obtain arc length. Equations are given in polar form or theta form. So we will use this formula directly. Integration of alpha to beta square root of r square plus dr d theta whole square d theta. Integrating the given function, proper limit, then we will obtain the arc length of the given curve. Find the arc length of the polar curve r equals to a1 minus cos theta. As we have discussed, we can trace this curve. This curve is in polar form, so we will trace, and curve looks like a cardioid. Initial limit theta equals to 0 goes up to pi and then 2 pi. So we can hold the limit 0 to 2 pi because we have to obtain the whole arc length, whole arc length of this cardioid. So we can use this formula, or we will use this L equals to 0 to pi 2 twice into this limit. So normally we are taking limit theta equals to 0 to theta equals to pi. Upper half portion we are integrating between suitable limits, and twice of that one we will obtain whole the arc length of this cardioid. So this is the way for finding arc length of this such type of curves. Now we are taking arc length L equals to twice of 0 to pi integration of square root of r square plus dr d theta whole square d theta. Because it is given r equals to a1 minus cos theta, so differentiating this one with respect to theta, we will obtain a sin theta. Then after putting all the values, r equals to r square, this is a square 1 minus cos theta whole square, a square sin square theta, and square root under root square root, we will write power of 1 by 2 like this way. So on simplifying this one, we obtain 1 minus cos theta power 1 by 2 d theta. And we know that cos 2 theta, relation of cos 2 theta sin theta is this way. If theta half, theta will be half here. So by using this result, we obtain 1 minus cos theta is 2 sin square theta by 2. Taking square root of 2 sin square theta by 2, we will obtain square root 2 sin theta by 2. For simplification of this integration, we are putting theta by 2 equals to phi. And if we are putting some substitution sub value, then we also change the limit, lower limit and upper limit. So lower limit will be 0 for phi and upper limit will be phi by 2. And after simplification, we obtain, or we get L equals to 8e. This is the arc length of cardioid E 1 minus cos theta. By the use of same formula, you can solve these some problems. Find the length of the arc of the cardioid r equals to a1 minus cos theta between the points whose vectorial angles are alpha and beta. Now we will use the same formula, arc length L equals to square root of integration alpha to beta square root of r square plus dr d theta whole square d theta. Then we will obtain this result for this question. Next question we have, find the length of the arc of the equilateral equiangular spiral r equals to a e to the power theta cot alpha. between the points for which the radii vectors are r1 and r2. By the use of same formula, we will obtain this answer r2 minus r1 sec alpha. And if you are facing some difficulties while solving or understanding these points, then you can discuss with me. Therefore, we will simplify again. Thanks for giving your valuable time and watching.